In this example, it's asking us to discuss each equation, that is, find the center, the foci, and the vertices of each ellipse, and then graph it using by hand. We're not going to use a graphing utility, much more difficult to graph it on a calculator. I am going to go ahead though and put a place for us to list all of our important things. They're asking us for the center, they're asking us for the foci, and they're asking us for the vertices. So I'm going to put major vertices and minor vertices, kind of abbreviating a little bit there. Okay, now there's also another problem here before we even get started. This is not in standard form. If it's not in standard form, sometimes we just can divide by something and get it into standard form, but that's not the case here. We're actually going to have to complete the square to get it into the proper form. Now the nice thing is we don't have to complete the square for both variables, only one. We have to complete the square for the y's because we have a y squared and a y. We don't have to for the x squared. If we had had x squared plus, say, 4x, then we would have had to complete the square for the x's as well. Alright, so what I'm going to do is I'm going to say we have x squared, we don't have to do anything more with that, plus 3. Now, the 3y squared minus 12y is what I would, well, I'll just go ahead and do that, and then I'll deal with that later. Minus 12y squared, we leave it blank, and then we move all of our constants to the other side, so that would be minus 9. Okay, now, we do need to complete the square, but we can't right now. We can't because you can only complete the square if there is a 1 coefficient in front of the y squared. So we're going to have to actually factor out that 3 before we can do anything else. So I'm going to factor that out and say that is 3 times y squared minus 4y, and then leave my blank, equals negative 9. Alright, now I'm ready to complete the square. So half of 4 is 2, squared is 4. Now normally I would just add 4 to the other side, but I can't do that because if we were going back and doing the distribution here, I actually added in 12 to this left-hand side because 3 times 4 is 12. So to balance it out, I have to actually add 12 to the other side. Now that's much more proper. And we can say x squared plus 3 times, now I can factor this perfect square trinomial down into y minus 2 quantity squared equals negative 9 plus 12 would be a 3. Now it's still not exactly in the right form because we don't have it equal to 1. So we're going to divide every term by 3. And now we have x squared over 3 plus y minus 2 squared. Now our 3's here will cancel, so I'm going to go ahead and put a 1 just so I can see that denominator, equals 1. Now this is in much better form, and we can go ahead and list out all of our important parts, the a squared, b squared, c squared, the a, the b, and the c. Now remember, a squared is always going to be our largest number here because it's along the largest side. So that tells us that 3 is the a squared and 1 is the b squared. And if you'll remember, we have that relationship between a squared, b squared, and c squared. That relationship is a squared minus b squared equals c squared. So 3 minus 1 equals 2. Okay, now we can find our a, b, and c from those. A would be the square root of 3. And remember, that came from underneath the x's. B would be the square root of 1, which is 1, and that came from underneath the y's. And c is going to be the square root of 2. And remember, a and c are always on the same line. Now we'll go ahead and use those and finish this out in the next video.